Hello everyone. Today we will be continuing our discussion of probability theory with an overview of expectations. So in order for us to really understand how expectations work and how we use them, we first need to understand the concept of weighted averages. A weighted average is basically where we have a bunch of numbers that we're trying to take the weighted average of, and each one of those has some kind of weight W that goes with it. So X is whatever numbers we're averaging together. These W's are our weights. And what we're going to do is we're going to multiply each of these numbers by their weights and then add up the total of all of those. One notable thing about this is that the weights have to all add up to 1. So we express these weights usually as a fraction or decimal. And of course the sum of those all has to be 1. So the classic example of weighted averages is when weighted averages are used to determine your grade for a class. So this happens to be the exact same system that I use for grading my class: 60% exams, 15% quizzes, 15% homework, 10% attendance. And let's say we have some example student that has this as their grades for all 4 of those things: 82 for exams, 68 for quizzes, 95 for homework, 100 for attendance. So in this case, our X values from this formula up here would be the grades, so 82, 68, 95, 100. These percentages right here would be our weights. Now, we have to think about these in terms of fractions or decimals when we're actually doing this part, but upon examining this, we can look at this and say, okay, 60% plus 15% plus 15% plus 10%, that all adds up to 100%, which is equivalent to 1 if we were to convert all of these to decimals. So, as far as actually taking the weighted average of this goes, we're basically going to take each of these grade values and multiply them by their weights. So 82, and our weight for that is 60%, that would be 0.6 if we convert that to a decimal. So 0.6 times 82 plus 0.15 times 68 plus 0.15 times 95 and finally 0.1 times 100. So if we put this into our calculators, what we end up with for our weighted average is 83.65. So this made-up student's overall grade in the class with this system would be 83.65. So now that we've talked about weighted averages, let's look at expectations. So an expectation is basically just a weighted average where the weights are probabilities. So we have some value that's associated with different events. We have probabilities that are also associated with those events. And we're going to take a weighted average using the probabilities as weights. So once again, just like with the weights for a weighted average, the probabilities all have to add up to 1. So an example that we can look at is, say we have a game where you have a spinner of some kind, and you can spin anything or spin A, B, C, D, or E, and based on whatever you spin, you get different numbers of points. And to make this a little bit more interesting, not all of these spins have the same probability, so I have the probabilities listed out in this column over here. So the way we would go about calculating the expectation for the number of points you would get out of a spin, basically, is we would just do exactly like what we did for the weighted average. We would take our points and multiply them by our probabilities. So for A, we have 0.3 as our probability times 1 plus 0.1 times 2 plus 0.35 times 0 plus 0.2 times negative 0.5 and 0.05 times negative 5. So if we actually multiply this out, this works out to be 0.15. So what we would say in this case is that our expected value of the number of points you get from one spin is 0.15. So what that essentially means is that, say you're playing this game and you're averaging more than 0.15 points per spin, you could say that you're doing well relative to the expected point value, versus if you're doing less than that, you would say you're not doing well relative to the expected point value. In the next video, we'll talk a little bit about some real-life scenarios about where expectations can come into play. Thank you for watching, and I'm happy to help with questions as always.